We'll be talking about content creation agent. If you have followed any of our previous agendas, our agenda is clear today. We'll be going through some basics about LLMs and also some agents, and then we will get into practicals where we are going to build a content creation agent using 3 different frameworks. And also today we are going to go through some code base, which is an open source project that we're going to make it open source, where you can actually make content, which is also video content. So we're going to see that overview. The code is quite huge, but I'll go through that code quickly. Okay, so hopefully everyone can listen to me. And now this is see my screen, which is large language model. So I just want to go through this again. If any one of you have already worked with ChatGPT, ChatGPT is a product that is powered by a large language model called GPT-4 or GPT in general, but there are different versions to it. Now we have GPT 4.5 that recently came out. So these large language models are built on transformer architectures, which are amazing scalable architecture that is been in the game since 2017. Google has introduced that for the research community in 2017, and it's very scalable. Things could be more generalized with transformer architecture. I think that's the reason why large language models are more generalist. They're not domain specific. When I say domain specific, large language models are not specific to one domain like medical or or maybe science or engineering. They are more general general purpose models which can take care of any questions that are asked. So there are tasks like text generation, summarization, translation. You could also use large language models now to even do reasoning, but we are not covering anything about reasoning now. We could do that tomorrow in tomorrow's session, but reasoning is also something that is happening now with these large language models. I think that is where all of the generative AI is heading towards. If a model can reason, it can actually provide you with better output than compared with other models which cannot reason. I mean, with GPT, the other models include like GPT-4 or which cannot reason. O1 can reason, DeepSeek can reason. So DeepSeek, the one that crashed in NVIDIA, so that can definitely reason. But we're not talking about reasoning models today. It's just large language models, and these large language models are powering agents, and this large language model is actually powering our agent to create content. So these are different applications: GPT-4 from OpenAI, Palm, and from Google, Llama from Meta. There's also Cloud from Anthropic, but there's open source and closed source. ChatGPT is a closed source model, so we don't know exactly what's happening, or no one has the model weights or anything. But if it is Llama is from Meta, they usually open source their model and the weights. So why AI agents over LLMs? I mean, why are we building agents when we have LLMs, right? I mean, we have ChatGPT, but why do I need an agent when I have ChatGPT is doing everything for me now, right? But the reason why, even though OpenAI is getting into building agents and providing agents as a service, recently there's a news where they want to sell PhD agents for like $20,000 a month, or some agents from $2,000 to $20,000 a month. So they're trying to build agents and they sell those agents. That is what they are heading towards, because even they want to get into this game of building agents. But why are we building agents in the first place, right? We already have LLMs. The problem with LLMs or the large language model is they hallucinate. They have some issues with in taking decisions, in being autonomous, in order to perform complex actions. I don't think ChatGPT could do it, or maybe other products could directly do it independently, because they need access to tools. They should probably remember. So let's say if you want to build a co-pilot for your doctor, or co-pilot for maybe your own co-pilot as a developer, maybe your co-pilot should be able to remember your previous progress that you have done in any of your tasks. It should probably remember, it should be able to give you ability to go ahead and push your code, or get information about new tickets, or review some PRs while you work on something important. So those are all different tools if you're a developer. But if you're a business owner, probably you have CRM that might require some information that need to be sent to ChatGPT. So you can't go ahead and paste that data into ChatGPT, or copy your information and paste into ChatGPT, because that might be sensitive data, right? You don't want to expose that. So agents would give you ability to use those tools and work on those tasks autonomously, and also process and do multi-step actions in, that is the advantage that you have. And those are all decisions which are not rule based anymore. Those are all cognition based, which are LLM driven decisions that you are trying to process. So, and agents, they do have APIs. They have various a database. These are all could be various tools. I'll go through separation, what makes an agent. I'll go through that. But the reason why we are building agents over LLM is to have proper integration, and also LLMs do have issues with hallucinations. They may not provide accurate information. So you need agents to do various patterns. You can apply different patterns to these agents to get the better output. So agent is a fancy word to doing a multiple API calls to an LLM. So once you get an answer to an LLM, or you get an output, you're again calling an LLM and asking, hey, is it answer right? Or do you think something could be improved, right? These are something that you would do with agents. So you're basically doing multiple API calls to an LLM, to put that simple. And if someone doesn't know what is an API, so just don't worry about it. I think there are some more things that I'll slowly translate to in the next slides that might help you understand it. But if you know what is an API, so agent is basically a wrapper that is doing multiple API calls to an LLM in different ways, and also having access to different tools. It could either be through API to do something for you, something for your business, or maybe that can help you to automate certain tasks. AI agents usually have these components, which I'm talking about, like that we can see here. So agent is powered by an LLM, which is a large language model, which inherently has this ability to plan out things. So it can actually go ahead and plan different processes. So you can have ChatGPT to go and think step by step. You can actually ask ChatGPT to do that. It can think or perform any action by thinking step by step. So that is what chain of thoughts is. Or you can even ask it to reflect on its previous output. So that is what reflection is. Self-credit is it can self-credit on its own output. So these are different ways in which you can have this LLM do the planning. So the LLM that is powering the agent. So that is one of the important part of an agent. And they could also be tools that it can use to perform some action, as previously mentioned. So it could be all of these tools, and these tools are driving it to perform a specific action. And it would also require memory to store all of the actions that it has performed. So it could be a short-term memory or a long-term memory. So short-term memory is something that that it has to store now in order to while performing a task. It should require some memory to either process information that is relevant to the task. Long-term memory is something that has to persist over time. Maybe some big events, like maybe an agent that notes down your personal information, or your personal agent should know who is your friends, who are your friends, or maybe it should know about your kids. It should probably know about maybe about your interests in restaurants. So these are some preferences that it should know, and it has to be in this long-term memory, because going forward, if you ever want to plan out a specific event, or maybe you want to go out to a restaurant, this long-term memory would have information about you, your interests, that it can properly do a personalized recommendation about. So those are some of the components that actually makes an AI agent together. And even though agent, as previously said, it is just an API call to an LLM, but if you really want to build a robust agent that can actually be continuously learning, and that is continuously improving, memory is a very important component. Unfortunately, today we are not doing much of memory in our agent building, because we are basically showing you introduction to different frameworks, and also we will have separate sessions later on to give you more insights into different frameworks to just building memory. But memory is a very important component for an agent if you want to make it truly personalized, truly hyper personalized, because that can remember things, that can actually get back and recover all the memories when it's answering a specific question. And if anyone has attended my RAG session last week, the RAG pattern could itself be a memory retrieval pattern, because when you're retrieving memories, it's a retrieval problem, right? You should be able to retrieve memories which could answer that specific query that someone has. So RAG could also be an important pattern here for the retrieval process. And agentic patterns, there are multiple agentic patterns. There's reflection, there's react. So reflection is something that reflects on its own output, and it just goes at and tries to ask itself a secondary question. If maybe a agent that is writing an email for your customer concern, it should be able to reflect and see if any of your inputs um, are, if the email that is generated is empathetic, or is it able to address the customer concern or not. So it should able to reflect on that. So just like how we humans do, even agents have the similar kind of pattern, which is reflection. They can reflect on their own output. And React pattern is very important and powerful pattern within agents. So if you're building agent, React is everywhere. It forms a basic building block for an agentic approach, because when you reflect, when you reason and perform an action, you should able to observe that and then perform the secondary action, follow-up action based on that. So if you see, the reasoning will produce different reasoning traces on how it has to address a specific query, and then it has to take an action on it. And once it does the action, usually the feedback loop, the observation, if that specific action is done or not, and if it is processed, then it's fine. Otherwise, it has to go ahead and again replan that specific thing. Imagine if it has to go ahead and book flight tickets, and if the flights are not available, it has to go back and give a feedback to you that, hey, the flights are not available. I try to use browser to check for flights. So that is what is important here. So your that makes this pattern more powerful. And you would also see this pattern everywhere, even in autocoders, like all of the automatic coding agents like Cursor, they use React. If you use them in agent mode, they use React, because once they write the code, there's some failure, they just get into the browser, take a snapshot, read the error, and come back and say, oh, there's an error. Now I'll just go and rewrite that. So it's a simple pattern that we all follow, React pattern, where we perform an action, see the outcome, and come back and replan it. So just like what we humans do, but now we are programmatically doing that with agents. That makes these agents so powerful, because the cognition driven automation is something really new to everyone, and we are just getting used to it. Because all of human history, there were no systems which can actually do proper reasoning. Most of them were rule based, but nothing was cognition based, which is just happening as we speak now. Prompt engineering is very important. I mean, this is not a prompt engineering session, so I'm just telling it's important to craft an agent. And in order to craft an agent, if you want to prompt it properly, you should know the domain. So in my case, it is content creation. I'm not a content creator, so I might not be the best prompt engineer when coming to the content creation process. Maybe there are some content creators out there. Maybe you would be the best person to create your content, and you would able to write a proper in English. You could probably draft the best agent outside that can do maybe the best content, because because you are the one who has been doing that, and you know what are the mistakes, and you would know how to guide your agent to do something better than others. So if someone says, oh, if you know prompt engineering, then you are the most valuable person, I don't think so, because prompt engineering with domain knowledge adds value, because you should know your domain. In my domain, maybe I would ask the right question, but if you're not the content creator, then you might not build the best content creator agent outside. And I'm agreeing to that. Whatever agent which I'm building today, maybe it not be the best. But if you're a content creator, maybe your prompt engineering skills would craft the best agent. It's just crafting your agent, but you might not, in order to build it, you again need people who can orchestrate things together, right? To build an agent programmatically. Maybe developers could do that. So yeah. So customizing interactions, effective tool usage, how to make use of a tool, all of them, you basically write in plain English and craft your agent to do something better. And you define the personality for that agent. So today we'll be going over like few frameworks. I think, okay. And one more thing is everyone will have ability to run this code through Jupyter Notebook. So because we have a platform called Agentversity, so you can all go through that. you have step-by-step guidance on how you can actually run through that code. But I want to give you a basics about what these frameworks are. LangGraph is a framework from LangChain. It's to build stateful multi-agent application. So I say multi-agent. So there is an agent. There could be one agent, but what is a multi-agent? So multi-agent is nothing but a process where you can, where you can actually not have one agent, but multiple agents talking to each other to achieve a specific task. So imagine like you want to build, maybe you want to write something. Um, then maybe let me give you a small example here. Okay, this is a travel AI agent. Okay, maybe I'll give you this example, or no, not this. Okay, maybe something like, okay, maybe an example where you need to create an app. Okay, okay, in order to create an app, it could be a huge task, right? App creation is not a simple process. So you probably need to have a writer who would write about all the tasks and how the app should look like. They could be a researcher who would, research about that specific, maybe market study, market research to see how many people are already using it. And then an expert engineer who actually goes there and write the product for you, right? So this is a huge cognitive workload. So I caught this, we can treat this as a cognition workload. If the cognition workload is huge, like creation of an app or creation of a design, there are a lot of agents now outside which can automate a lot of things like, hey, this is my law agent, right? Or maybe it's a deep search agent that does a lot of deep research. So it has to create, it has to do a lot of research on a specific topic. It could also be a co-pilot for doctors, like some agents are actually helping out to do research on a specific condition of a patient. So in order to do that, you could directly create one agent, but if there is a huge cognitive workload, you probably have to reflect on it. Even if there's an output, you have to reflect on it. So you are modeling exact hierarchies that a team actually has, right? When you want to create an app, you actually talking with a project manager, you would have various developers, you would have a scrum master. So you could model all of these agents together and have them like a team and then work together to achieve a specific task. So that is what a multi-agent frameworks are. So LangGraph can help you build that. And there are a lot of cognitive tasks that should require not one LLM call, but multiple multiple agents. And okay, people might say, okay, why are we doing this multi-agent? It's just about the pattern of, I call it a reflection pattern, because that is what reflection is. I mean, reflection is, you have an output and now you're reflecting on that output. But multi-agent is multi-agents are actually reflecting on it by assuming a persona, right? You have an output that is generated by a developer agent. Now a tester agent should able to, provide its feedback on it, right? So you create your own tester agent and create a persona. Okay, you're a tester, you are best tester in the world, and you probably need to go out and test this code and come back with a feedback if it's running or not, and you give it a prompt or maybe an interpreter to, or a development environment or test environment to test out the code and give the feedback. So now you can create two different agents and have this one output is reflected by the other ones. So that way you're making your output better. It's just, scaling up this pattern of reflection, right? And so that is what you're doing with multi-agent. So you can build multi-agent agent applications with this LangGraph framework. There are a lot of people already doing this. Replit agents actually uses LangGraph to build those agents. You can actually tell Replit to build, hey, let me build this app. It does all the building by itself. It just asks you for some for some approvals, but it does all of that building process by itself. It basically is LangChain framework. It also provides a human in the loop capability, which is really important. You always need to have human in the loop. You can't just trust everything that a AI agent does, because AI agent tend to hallucinate. They are not perfect. You can never tell AI agent would have the same behavior 100% of the time. You can improve it. Now there are systems, people doing RL to improve and make these agents very accurate. Reinforcement learning is definitely picking up now to make these agents more accurate, but still there is room for error because these are probabilistic missions. They are not deterministic, right? You write an application, you deploy in prod, your application doesn't change, but your application would always do the same. You can say, okay, this is my behavior of the application, and this is how it has to behave. But AI agents aren't like that. You always need human insights if in case you're making important decisions. If you're making a decision to just draft an email or going through documentation, maybe it is not a critical decision, right? Maybe agents can help you out. Maybe there's some issue. It can hallucinate a bit. You can make the system a bit more, but even the mere error, right? The impact of error is not that huge. But with some critical systems like medical decisions, or maybe something like decision making to that can impact, that have huge ramifications, you should always have human in the loop. You can't just give tools and have agents do everything by themselves. So LangGraph structure is basically through nodes. You define LangGraph itself. The name itself says that you have various nodes for different tasks, and each node, it could be node 1, node 2, node 3. You define different nodes. Every node could be an API call to an LLM. You can say you can treat each one to be a specific stage of a process. And then you can create conditional edges on how specific, either the process has to be driven to other node, or how it has to route that request to various other nodes. So you're basically mapping a given cognition task, and you're not just giving all control to an LLM. You're not telling LLM you just go do whatever you want, but you're kind of putting a guardrails here. You're telling LLM, I give you a request, and this node might make a call to an LLM, maybe to do to find out if flights to maybe flights to India, and then or maybe flights to Bengaluru. Then usually it has to go and check if it was able to find the flights. It did not find the flights. If it found the flights, then probably it has to go ahead and make the booking for hotel. But if it did not find the flight, there's a condition here. Then go here and look for different websites, or even if all flights are booked, go ahead and look for bus, or maybe some other public transport. So you can create this guardrails, and you can define your cognitive architecture on how these LLMs have to be routed, how their thinking process should guide them to do something achievable, right? You're putting these guardrails in picture. If you just go and tell LLM, you just go, get me these bookings, there is a very high chance it can hallucinate. It can just go and do some other action, or maybe someone coming in and they might ask, okay, just go and write a Python script instead of actually doing a booking for you, right? So you have to put these conditions to make sure that there is a check on every workflow, and you can define that workflow. And LangGraph gives that ability to control that. So you can have this dynamic routing and determine how this operation has to look like. A traditional automation workflow, nothing that fancy. Travel AI agent, I mean, I made this diagram actually for travel AI agent that we had before, but I can just go through this diagram. So how it works, okay, you just start, you have an agent. It will go ahead and iterates through this tools. A tool could be anything. If in case it could be a flight search or a hotel search, it just goes on and looks for that and continuously make use of tools to come up with an output. And then if it is done, it is done. But this is the basic React. But there is something called a structured output that we'll be using in our agents now. I'll showcase that in our video agent. So in that case, in structured output, what you're trying to do here is you respond back with a specific syntax. There's a process that you have. You respond back with a specific output, and then that based on that you have next series of action that happens. So there is a structured output that these LLMs are good at. These LLMs are really good at responding back with a specific structure. So you can you don't have to do any pre-processing. You don't have to write extra code to convert that into JSON or anything, but you can just ask LLM, hey, can you just go and respond back with this structure so that my downstream process shouldn't have to I don't have to again write Python code to reprocess it. So that's a very valuable use case because it is saving a lot of code. You don't have to do a lot of transformations or anything. Rather, your LLM it's your LLM responsibility to reply back in a specific output. So you can also reduce a lot of iterations as well here. There's one more framework called CrewAI, and we'll be going through that framework shortly. So it's also a similar framework where you're building, as I said previously, when I talk about multi-AI agents or multi-agent applications. So CrewAI, the name implies crew. You're building crew of agents that are working together to achieve a specific task. And it's a very simple no-code tool, a low-code tool, not a no-code, but a low-code, because there's not too much of moving parts here. It's pretty much abstracted, a lot of things. You just have to tweak a few files to build an agent here. And Python is the language that anyone can use and build this. And this is overall framework how those crews are built. There are different AI agents, and you have a central process and different tasks. So task is something an agent would use tools to achieve, or a task is something agent should perform or to do a specific action. So the task could be anything. And processes are something that will define how every agent has to work together. So that is how overall things are arranged in CrewAI. So Crew organizes the overall operations. Agents work on those specified tasks. All the process is actually putting the collaboration into picture, like how they have to collaborate, and tasks get they have to be given a goal. All these tasks together would achieve that goal. Similarly, right? I mean, process and everything, they are basically creating a guardrails to achieve a specific goal, because you don't want LLMs to hallucinate and just iterate and loop and burn tokens. So that is just like how LangGraph has this conditional edges, or where you can put guardrails on how your specific automation should look like. So just CrewAI also has the same guardrails, and this is what these guardrails are made up of. So today, let's go ahead and do this content creation agent. I'll go ahead and share you the Agentversity URL that everyone can follow along, and just go ahead and use that to build this agent. So you can just execute that. I will I'll just go ahead and share
I
Agentversity.
shared, Raj, I shared. Yeah.
Yeah, you can just go through that Agentversity URL, and I'm sharing the before I can share the URL, I want to showcase the before showing the I'm sorry, showcasing the notebook. I want to showcase the diagram on how this is all done. So the content creation agent, it got multiple nodes. We are using LangGraph to begin with. This is all LangGraph code, and also we have CrewAI too, and we have no code tool as well. We're using like N8N. So you start. There is an understand query which will check if does this query actually require tool use. So maybe I could just ask, hey, can you maybe something like can you just tell me a joke, right? LLMs can actually tell you a joke. You don't have to use a tool, because LLMs already know some jokes. But if you ask it, hey, can you go ahead and create maybe some content related to OpenAI's recent release of GPT 4.5? It should require a tool, because these LLMs, they have inherently problem of knowledge cutoff. LLMs cannot understand. I mean, they only know facts about at a certain point in time. Like last April is the cutoff for most of these agents. Most of these LLMs, like OpenAI has this LLMs which have a cutoff. Till maybe April of last year. So they don't know any recent events. But in that case, if you want some content to be generated for this recent OpenAI 4.5, then it has to use a tool to do research and get that information and then respond back. So this is where the understand query step comes in, where it understands if it has to use a tool or doesn't have to use a tool. If it doesn't have to use a tool, then it just goes here. It generates a path on either to generate the artifact or rewrite the artifact, depending on what it has done previously. If it has already previously has generated an artifact, it will just go rewrite it, or it will just generate a new one, and it will just go clean the state and checks if it has to continue or not, or respond back. If it has to use a tool, it will just go use the tool. And again, the same thing follows. It generates the path on either to the generate path is either to generate artifact or to rewrite the artifact. Artifact is something that it generates. It could be, a blog or maybe an article or maybe a LinkedIn post, maybe a social media post that you want to put out, maybe a tweet that you want to put out. So yeah, something like that. So you can actually generate and rewrite those paths iteratively. So this is the overall workflow for your content creation. And then I'll go through the other workflow, which is for the video generation. But yeah, this is just for the basic content. I'll just go ahead and share Asian University. Okay. So there you go. This is Age University portal. So everyone, if you want to learn this, you can come here and, you have no code, low code, and code option. So I'm just going into the low code option. So low code is for the CrewAI. We'll be using CrewAI. And here is the code option, which is the LangGraph. And this one will be for the actual code. So let's go to the LangGraph code to begin with. So let me just go ahead and execute this and show you different steps to this. I'll run all cells. But yeah, so what you're doing here is we are installing all of the modules which are needed for your content creation agent, and we are using LangGraph, LangChain. So we are just installing them. And coming to the other steps here. Just a minute, I think. Maybe let me just come down and restart this kernel because it looks like it's kind of frozen. Yeah, I'm just restarting this. Yeah. So let me come here, click on run all cells. Yeah, there you go. So you have this, all of these modules are installed, and then comes the other modules that we need to install, which is like logging, date time, and you have other modules which are installed here, which is from LangChain. You have base model. Pydantic is really important here because Pydantic, as I don't know how many of you are already working in this space, but Pydantic helps you create, data models that can help you to build these agents with specific data model. So yeah, you can see this there. We have base model and field. These are two things that are really powerful in order to in order to craft an agent. And you see here, we also have memory. So we are also using checkpoint memory. Checkpoint is the memory within LangGraph. That is LangGraph native memory framework that you can make use of. We are not using any frameworks, but we're basically using this. And here you have all of these messages, human message. You have these are some of them that you can make use of in this case, for building this agent. You also have state graph end. So these are all, when you're building your graph, you need to create different edges. You need to make sure that you have all of the states defined, because as I said, state is LangGraph is really powerful because you can build stateful agents. So stateful agents they remember what was the previous execution. Let's say if something happens to the execution, they still know where they left and they start from that state because it always maintains the state. That framework is enabling that to build a stateful agent. Here you are building the state classes. So you're using base model from Pydantic, and you're building this artifact on how this artifact has to look like. And your artifact is basically the actual content. It could be a blog post, tweet, or anything. And here you have a title. So you're basically creating a base model and crafting your artifact, how it has to be. And then you're also crafting your state on what, state of the current creation system, right? Content creation system. So what is the current state, where we are with it? Are we at generation stage? Are we at the query stage, or all of that? That information is actually stored here. And now the core agent functions. So this is where you are basically modeling all of the functions for your agent. And in this case, you're using various tool calls in order to get information from internet. So what is the tool that we're using here? It's called DuckDuckGo. So this is a tool that we're using from our agent. DuckDuckGo is a search engine. So just like Google, it is a search engine. So it has to go out and get the information from the internet, because as we know, LLMs doesn't have current knowledge. They make use of these browsers to get the current information. So you're basically using GPT-4o model. And this is the first stage that we define in our diagram, which is the understand query stage. So in the understand query stage, it is understanding the query and deciding if it has to use the tool or not. And you're basically, if you see here, it's actually trying to invoke this tool based on its persona. So you're giving it a persona saying that this is the system message. You're telling you're a helpful content creation assistant. You see that is a very small system prompt, which I feel like, if you really want to make it robust, you could, but just for the sake of this example, we just created a small prompt for it. And then if you see here, if there are specific tools, or it has to call the tool, then this is the it has to go ahead and use DuckDuckGo as a tool call, and use that to respond back. So, and here you're generating the path. You're generating if the path is if you're generating the specific path around which specific action to take, either to generate an artifact or to rewrite an artifact. So are you asking this question related to the things which I have previously developed? Maybe a tweet that is developed, that is deployed, or that generated, you want to make edits or updates to it, it will be a regenerate or maybe a rewrite artifact path that it has to take, where it has to rewrite that specific artifact. And here you have this content generation functions, where you're defining how the generation artifact has to work and the rewrite artifact has to work. And all of these are, just LLM calls. You can see that to the LLM to get the response back. And here you're building the graph. The graph is actually, you're telling how your entire system has to behave. That is a powerful way to put these guardrails in LangGraph, as we previously spoke about. But how do we create it? Basically, we have to add different nodes and create conditional edges on that. So here, if you see, we are basically adding all these nodes. What are these nodes? Understand query, generate path, tools, generate artifact, and rewrite artifact. These could be all different nodes that your graph has to use to build the system. And what are the edges? First edge is the understand query, and then comes the conditional edge. Conditional edge is either to use a tool or not to use a tool. So you can see that here. Based on this understand query, it will either get and do a tool call or just generate a path directly. Path to either rewrite query or rewrite an artifact or generate artifact. And here you have you're just going ahead and using this content creation agent, and you're just exposing that to an API because it's working in a Jupyter notebook. So we have an interface on how you can expose it and chat with it. So let me go ahead and open this link. In order to get the link, all you have to do is you have to go into your tutorial page, wherever you have this tutorial. Come to the end of the page. Here you will see an endpoint that you can open and check if you can. Yeah, there you go. You can actually see this UI where you can actually ask it to generate. Maybe can you generate a tweet on GPT 4.5 release from OpenAI? So now what it is doing is it will follow all of that path that we defined previously, exactly um, how to generate this specific tweet and understanding the query. So there you go. It's not just generating the thing, it's also actually, creating an image here. We use some APIs to do that from the code wise. So you can see here, this is the tweet that it has created. But you know what, I might have to change it and tell, can you update this tweet for a LinkedIn post? So so it is just going ahead and probably create a new, you're basically going a rewrite artifact. So it will probably rewrite this to that is suitable for our LinkedIn. So you might able to do this entire thing through maybe through just going to ChatGPT and generating, the specific, content that you want, according to your requirement. But this is basically a simple basic pattern that you can use to make it more robust, right? You want to write blogs, but the blogs have to be according to your own information, according to your own company standards. Then you could add more context to it. You can create more memory to it, where you can add all of the previous information or the previous marketing that you have done, maybe add more information about your own internal product, and you can probably generate content that is personal to you, just like other custom GPTs that ChatGPT came up with. But this, whatever we're talking today, is the basic, simple implementation of content generation. But this can be extended to a lot more that we will see later on, exactly how we are going to do that with videos. Even there's a lot of room for improvement, but even here, you can actually add multiple tools too. And if you see here, one thing which I don't like about this is, you can clearly see it is ChatGPT generated, because there are emojis, and there are these emojis which can definitely make it ChatGPT generated. So can you make it sound human? Please. I mean, I usually don't like to. I usually like to have, because anyone can actually tell that it is ChatGPT generated, because you see the language. Language is very easy to mention. I mean, I have a lot of experience with it, because now I see so many resumes, like while hiring. So many resumes, common pattern. Now ChatGPT talks about percentages. Every point has a percentage. They say, okay, you know what? I have experience doing this, and I improved 10%, 20%. That is a clear sign that is ChatGPT generated point, because these percentages clearly, that is how, if you go into ChatGPT and say, hey, can you give me a resume points for this, it will 100% of the time it will give you some percentage in there, where you say it is actually 10% improvements or 20% improvement on the task that you have done. So because these systems are all developed by something called RLHF, which is reinforcement learning with human feedback, where human feedback is really, that is, you're just basically mimicking human feedback. So they're just mimicking exactly what people are meant to be doing, right? So you see it just removed all of those emojis and just sounding a bit more human, because previously it was sounding a bit more like, I don't know, maybe a bit more chat GPT-ish. So now we have this. Same thing you can do with low code, and low code also, you can have the notebook here on how you can generate this. There are different steps on uh, CrewAI is pretty simple and straightforward. You define everything as bunch of agents to come up with a specific outcome. I come here and do run all cells. I don't know if this is running. So you have the similar approach. You have CrewAI. You have all of these steps that you can that we discussed before from CrewAI module that you can get from CrewAI: agent, task, crew, and process. Which these are all make up a specific, which all handle a specific cognition workload, or and this is DuckDuckGo, exact same tool. But the way we are defining agents is a bit different here. We're not defining that nodes and edges that we have done in the LangGraph side, but rather we are doing it more of like giving it a persona, just like creating a crew, where one would be a research assistant, one would be a content writer, one would be a content editor. That way we are creating the same kind of abstraction or same kind of graph that we did in the LangGraph side, but the LangGraph side is a bit complicated with nodes and edges. I think only someone who's a developer can understand all of it, who can understand complicated code, can feel comfortable using LangGraph. But if you are really new to this and you want to build some agents, CrewAI will be your best way to do it, because all you are doing is just writing what everything has to be. You're just defining how a researcher has to be, a content writer and a content editor. If you see in the LangGraph side, it is more of a node that is, and defining the paths to different nodes, where you have generate artifact, and one is to rewrite those artifacts, which even the language is not, maybe someone who's a developer could probably be comfortable with that, but maybe not everyone. But that's the reason why, it's kind of a low-code tool where you can define the role, give a goal for that agent, and what is a backstory. And you're also telling if that requires a tool or not, right? So, and you're also telling here exactly the same thing. And here it is a content writer, and this is the content editor, where after the research is done, your content writer will actually write it, and the content editor will edit it. And here you see the task for, you define the task and you link those tasks to these agents. And you see, this is the task of researching the topic. And this is assigned to the agent researcher, that you can clearly see this here. And here you have a writing task, which is assigned to the content writer agent. And here you have the context that you're passing in from the research task. So once the research is done, that context is passed here to this task to enhance the output. And here you again have the editing task, which is a context coming in from the writing task, and you are actually giving this to an agent called editor that is right here. So once this is done, you're setting up the crew here. So you're creating the content crew. So it's a very simple, straightforward way to do that. On how to set up a crew is just a command that you can create, and you assign how many agents, number of tasks that you have already defined here. And verbose is 2. So verbose is basically giving you how well you have to give the outputs of how the process is happening. And here you're basically doing a process.sequential. So you're either doing this process in a sequential way or parallel way. So, but here we want the process to be executed sequentially, because things have to be done in a sequence, one after the other. But they could be processed, it could be done in parallel as well. And here you're just exposing this entire thing. So how are we going to run this? Basically, let me go ahead and restart my kernel. I don't know if that was causing some issue here, but yeah. And yeah. Yeah, so it's done. I just ran, executed all of it. And no, I think it's still going through here. Once this is done, you have this executed. And now, okay, there you go. Now it's executed. Now we can actually access the URL, and the URL is actually here. Yeah, if you click on this, it opens up the same thing. So it's just the framework difference, but the output and everything would probably be the same. And this is the no code tutorial, which I mean, it's through N8N. So anyone who are interested to implement this, please feel free. You have it on Agentversity platform. And you also have a video here that showcases on how you can actually do this specific implementation of AI agent in this tutorial video. And you have all the steps on how to do it. So feel free to go ahead and implement. This is very straightforward. And then you can, let us know your feedback. I'm not going through that because of the other tutorial that we have, that we might go through a content or a video generation. So video generation, we have just open sourced that tutorial that's a bit on the content creation side with the video content creation, where we are working with a lot of APIs. So we are using File AI to get that information, to get that code. File AI to interact with a lot of video maker APIs. But I will go through this through the slides to show you the diagram on how that works. If you see here, basically the content creation, which is the video content creation agent, first thing, it starts off with the project description. Basically, it does a deep research on that topic. So it could be any topic. We can create some videos on, maybe some videos on different, I mean, before doing that, I think let's go ahead and start off with the video creation, and then I'll walk you through the steps on how it is happening. Maybe because that actually takes around 7 minutes for us to generate. So, and I was executing that on localhost 3000. Let me share that part of the screen. Yeah. So this is the video generation part. So I'll come here, I want to create something maybe on, I want to create a small video on some topic, maybe some title. It could be maybe some enterprise. I've previously done some videos on some enterprises, or maybe I could do it on maybe a event as well. So maybe Diwali, or maybe some festival, or any of the specific events. So maybe can we do it on Holy? Let's see if we can do it on Holy, and I'll just make it create a around Holy Festival. Please do research to learn more about it. So I'm just want to create that about Holi, and I'm just giving target audience. I want to generate for Instagram, social marketing. I'll just do social 30 seconds English. So we also have some other ways. We also can integrate other languages too. But in our case, in order to do that, there are other APIs that we can follow. But this is only English to be specific today. Uh, but you can actually do that. We'll put that in GitHub on how to do it for other languages. But yeah, style is realistic or cartoonish. I'll just put realistic and then do create project. So what it is doing now is it's just going ahead and creating the project and creating the video. It might take a while. So let's go back and see the overall flow and how it is working. So basically what happens is once we gave the project description, if you remember where I'm talking about Holi and I gave it a project description on, hey, Holi is a festival and please do research. So it is going ahead and doing a deep research on it. Deep research is it goes out into internet, looks for different sources and looks for what is it about, right? You can give any company's details as well. It could be your own company details, but you don't have to, you can just say, just go out and do deep research on your company. It will probably go ahead and look for what your company does, any new recent news and any news events to get more context about that. And then it does self-reflect. So this is one of the important pattern within, as we discussed before in agents, it does self-reflect on what is important for it to make a video. And after that, it creates a script on the video has to be, what it just makes a script about that video, and it creates a storyboard about that specific video, how it has to be, how the video, what would be the timeline. If it is 30 seconds, how it can divide that into the 5 seconds each, and how every story has to look, how the transition has to look at. And then it creates video shots. So after it creates storyboard and then the video shots, which will be, these are all these three steps are basically three or different prompts that are created that will be sent to different APIs, right? Video, creating audio clips, creating voiceover prompts, or there's also one more section is creating the actual video. So these are all actual tasks that the agent would be doing. But this creation process is basically all of different prompts that are created to make that specific script. Imagine yourself to be a video generator or an advertisement maker. You need, if it is 30 seconds, you need a script for that 30 seconds, right? You need a storyboard on how your story has to transition and how the story has to look for different snapshots within that video. And also you need to describe every shot of video, how it has to look like based on the context. So that is what's happening under the hood. And it will create the audio clips and other, even the voiceover prompts as well on how it has to create the voiceover and also what music it has to play in the background. So we have all of these taken care of in the code. I can go through the code. The code is quite huge, but I will just walk you through some basic. I don't want to um, walk you through the complete. I don't want to walk you through all of the code that is on the application side. There is front end code. I don't want to walk you through the front end I just want to show you the back end code. We have used CrewAI for deep research, and we have used LangGraph for content generation, mainly the script generation and prompt generation for video shots and all of them. So it's a blend of it's basically a blend of tools that we have used, a blend of frameworks that we have used. So you don't have to always go with CrewAI and always go with only LangGraph, but you can make it blended if you're building some agents which are complicated agents like these, right? And so I'll just cover up the backend part to this. So I'll just swift through this. Not cannot explain every part. It's like 1,000 lines code. So, but yeah, what I'll do is here we are using, Pydantic as previously as said, we're still using the same LangGraph things. And we're using Fal AI client, which is the client that is used to interact with Fal. Fal is basically a platform on which you can access many models. The only thing that you're going to do here that you need for running this locally on your machine would be a fall API key. You get into fall, I think they give you like $25 or $20 credit. I'm not sure, maybe $5. But you can go in there and get some API key and use it and generate your videos. Okay, there's the only API key that you might need, and also OpenAI API key. There are two things that you might need in order to run this. I think it's part of your README file that I can go through after going through the code. I'll give you a README file. I'll go through the README file. But here, if you see, there is OpenAI API key and Fall AI API key. You probably need both of them, and you're using GPT-4 4 to generate prompts and all. And then what you're doing is you're basically creating, and here it's all SQL alchemy and all of it, because a lot of things that come from Fall AI, it's a lot of metadata, there's a lot of videos that are generated on a different platform. So every short of video usually have a URL. So we're storing them on SQLite locally. But yeah, so if all of you have Docker, it's very easy to spin up. I'll tell you exactly. If you have Docker, then it hardly takes you like a few seconds to get it up and running locally. But yeah, so here you're basically building different classes that are various tasks. It's basically structured output. And you're creating this model that can be used by other agents in order to, do if you want to do a video generation request, what are the things that you might need in order to do that, right? Video generation, when you're doing an API call to that specific endpoint or the provider. And this is a short result, error response, how the video script has to be, storyboard has to be. So you're creating this all a data model for all of these different actions. So, and you're using base model, which is actually from LangGraph. It's all powered by Pydantic. All of this under the hood is powered by Pydantic. And here you're basically defining all of these models on how the video task has to be. And you have single generation tasks, you have video export. So these are some other functionalities that are there within it. And agent state is something that is actually with LangGraph. You have something called an agent state. It is basically your data model for how all of this agent, every node has to look at, how every node has to look like. So if you see how the agent state is, you're basically creating a state graph with this and adding your basically to create script, to create storyboard, and to create shorts, because these are the actions that are powered by LangGraph. The other steps that we have gone through in the diagram are actually through CrewAI, some through application itself, right? There are some steps to generate, to do some more deep research, or maybe some things to generate the actual videos. Those are kind of tool calls to it, but we haven't defined any node. It is all done programmatically just using Python, because it's just an API call to that API endpoint like Fall AI. But you can still make it LangGraph native as well. But, for this sake of this tutorial, we haven't done that. But, that would be maybe a next enhancement that we will probably need to add. Or if anyone wants to add it, please feel free to contribute to this GitHub project that we'll share. But yeah, create script, create storyboard, create shots. So these are three different nodes that are there as part of the LangGraph framework, where you're creating all this, and then you're generating the video based on all of this information. So within this video generation, you're basically sending. So if it is 30-second video, our framework will divide that 30 seconds into 5 seconds each. So it will be 6 small videos or of 5 seconds each. And it is making requests to Fall AI. Basically, first thing is it has to generate an image. What it does is it uses a model called Flux to generate image, because image would be, what we're using is the image to video models, not just text to video models, because text to video models hallucinate a lot. So we used image to video models. We are using Kling in Fall platform. Fall AI is a platform to host all these models, but we're using Kling model, and we are using image from Flux model. I mean, even if this all sounds really maybe you're not aware of it, or it sounds complicated, you can just ignore. I mean, I've put everything on README. You can go through that step by step, and please don't be overwhelmed with all of this different kind of names. But if you're aware of it, yeah, this is what we're doing. We're using Flux to generate the image, and then we're using Fall to create a video with that image. So we generate 6 images for 6 different small shots of videos, and each image is extended into a video shot using Fall AI. So we're making 6 different calls to Fall AI and telling, hey, this is your image, just go make a video of 5 seconds short, and this is your prompt to make that. And all of these prompts are created by OpenAI, where OpenAI knows that it's a content creator, and it is making these prompts to make that entire video a advertisement or something like that, right? So that is what it's doing here. So and you have different styles that you can define about video styles and image to video, because as I said, we are using image to video, not text to video. So once we generate the image, we're sending that image to Fall AI, maybe the Kling video to generate that, and then you're adding this entire thing to to database. Maybe all of the information that you get out from the task is nothing but, since it is Fall AI is a platform, so every job we are asking them to generate this content. So each and every request has a task. So we're following up and seeing how much time it is taking. Like usually it takes 6 minutes to generate a video. So that's the reason why I'm just, while I started that task, and then I'm taking a presentation because that's still happening in the background. We'll go back and see whether it's completed or not. But yeah, so you create this video workflow where you are creating a script, storyboard, and shots. These are basically prompts that you're sending to a language model that is generated by a language model. And these will all add more context to that videos that we're generating. So we have already gone to this create shots, and here you're actually telling LLM, what are you? We're prompting, we're creating we're crafting the personality of it using prompt engineering. That is what we're doing here. So you're a professional video production expert, cinematographer, voice director, and then you're trying to do this and make sure that the video has to be this way, it has to be engaging and all of that, right? And then these entire information, all of these shots, everything that is created here or created storyboard, these are again translated are sent into the create video workflow. So all of this create storyboard, all of them are added to this, and and coming down, okay, get status, and these are all framework specific. These are all app.orgs or Flask specific, just to create different routes to find out the task ID for different APIs and all of it. So it's all application specific. I'm not talking too much about this because that will be way out of scope for this presentation today. And yeah, I think I'll go to the README. There's also other application specific thing. There's regenerate shot background, a lot of tasks. If you can go through this, and if you want to contribute, please feel free to contribute to this. I'll just go ahead and let's see if there's a video that is generated, and then we'll come back to this. Okay, what is that video generated about? Holy, right? Okay, let's see. Oh God. Okay, there you go. It failed. I don't know why it failed, but we can see the logs on why it failed. Okay. So let me share the screen. There are some videos that we generated prior. I can share you that, but I don't know. There's some issue and it failed today. And this is the Docker. I'm just going through this on what happened here. Okay, there is some error in this in the Docker file because it was not able to download some image, and that is what this error is. You can see that in the Docker file. Sorry, in this Docker logs. Maybe we'll fix that. I don't know exactly what could be the error. We'll do the root cause for that. But yeah, if you want to see the previous videos, I can share you that and also share you what is this issue that we saw here in this. But this is open source, so we'll share you the GitHub as well. Let me go ahead and, oh, I don't know if it's redoing it. It was redoing it. Let's wait for it, but no, I'm not sure. But yeah, let me go ahead and show you of some companies that we used previously. I think this is our OpenAI. I think here I have, let me show you some content that is generated for other platforms. Okay, so yeah, so this is the ad that is generated for OpenAI that I just prompted like not too long ago, maybe just before this meetup.
Welcome to OpenAI, where the future of artificial intelligence is unfolding today. Our diverse teams work tirelessly to advance AI for everyone's benefit. Meet JEP-4.5, enhancing conversations with its intuitive and intelligent, empowering educators and developers through community-driven AI workshops. OpenAI and Microsoft Azure partnering to bring AI to everyone.
So if you see, it's not 100% perfect because of the model that we're using is the cheapest model. Generating video is not a small thing. I mean, it's not cheap thing. It does take some expenses there. You know, it does probably it costed us a dollar, probably dollar or dollar and a half to generate one whole video. It sends 40 seconds per video, so it's probably $2 every video that we generate. So it is creating snapshots. Sometimes, you know, the model doesn't generate everything perfectly. Sometimes it can. So there's a lot of room for improvement. But yeah, it's a good start because just doing everything in one shot. We're still trying to improve that. And if anyone wants to collaborate on this, you can. And this is something around serve crust. Oh, this failed, but there's some more video that probably, because there are sometimes we see some failures because of tightly coupled with some external third-party vendors. So let me go back. Okay, this is something that was done on Instagram that was generated for Instagram. So this serve crust is a I think it's a company in Hyderabad, based in Hyderabad. They develop they deliver a lot of these raw materials for mainly for businesses and all. To see here. So yeah, this is generated. I feel like one of the biggest thing that is missing out in this video, and we haven't added deep research then because deep research was not able to tell that this ad should be for someone South Asian, right? We probably need all the subjects in that video to be South Asian, not because then it will be more personalized. Now you see different cultures in it, then it is not personalized. Maybe, you know, someone might not connect to that because it has to be native to the people, the business have to generate ad which might be where everyone can relate themselves to. So later on we add deep research now. So deep research will actually make that a bit more personalized. Okay, maybe I don't want to regenerate this. I think there's some issue going on, but yeah. I will go through this GitHub code that anyone can look at and clone and run it locally. And we will publish, we will see once that is fixed. I feel like it is some issue with the integration, but once we fix that, we will able to get you uh, share that information with you on what was the issue there. But yeah, let me go through that code here. I think it's in my team's GitHub.
Raj,
So
you
what
will
I
be
do,
answering questions now or
yes,
later?
yes, I will be answering those questions now. I just want to share that repository
Okay.
and then I'll answer the question. Yeah. So anyone has any questions? I think there are a bunch of questions. Probably I'll probably look at it. I'll try to answer as many as possible. But before that, I want to share this.
Participants can raise their hands and I will unmute you one by
Let
one
me
and
go ahead
then
and
you all can
answer that.
ask.
Sure, once we fix that code, probably I'll share that code base with you. But yeah, now I think there are some people who have already raised hands. Mm. Yes, Vinod, you go ahead.
Yeah, hi Raj. So how can we run this locally? Could you take us through that?
The content creation agent.
Yeah, the video
That
generator agent.
Yes, video generation agent. So there is a way in which we can do that. Basically, we have Docker files so that you can use to run this locally. So let me show you the Docker files that you can use to run it locally. But as of now, I think we'll make a fix of that and then we'll give you a way to run it locally. But I'll share you my screen to show you exactly um, what do we have here. So there is only few commands. You just have to change two files and do Docker compose up and build. This is one command. These three commands enough to get it run up and running. But you should know Docker. I mean, do you know Docker? Vinod, can you hear me?
He can hear
Okay.
you. Just a moment. Let me just unmute him.
Yeah. Okay.
Yeah, yes, Raj. I know Docker.
Oh yeah. Then if you know Docker, it's very simple. It's just few commands. So
Okay.
one, I'll share the code. Maybe we are missing something there, so that's the reason why it's not properly working. But I think once we fix it, I'll share the code base here in the group, and then you can just go through that and work on that project
No,
for
Raj,
yourself.
Raj,
Yeah,
if
sure, Raj. That works. Thanks.
Yeah,
It's a
thank you.
very informative session. Mm,
Thank you.
It's good.
Thanks a lot.
Thank you so
Please,
much.
yeah, please share your reviews on Meetup if possible. Yeah, thank you. Nidhi, can you go ahead?
yeah, Raj, one more thing before you step up. Your Docker containers are stopped. That's why that was not working. So if you restart your containers, it would run basically.
Oh, did you think it stopped? That's the reason why. I think I got it up before, right? No,
Yeah,
before this call.
but if you go back,
Mm.
basically the page does not load and the container stops. So if you stop those containers and rerun, you would be able to run that project as well.
So let me do that. I'll just go and rerun that. And let's see. Okay, I'll just do a Docker compose up again. Let's see. It should ideally run. Okay, so let's wait. I'll again reinstate. I'm again restarting that video generation process. So let's see if it generates about holy here. Let me go ahead and do that. Yeah, Nidhi, can you go ahead with your question?
Yeah, thanks, Raj. First of all, thank you very much for the wonderful session. I have some couple of questions, like as you mentioned earlier that LLMs hallucinate. So this AI agent is not having that problem. So can you little bit elaborate what is added in this agent, which was not there in LLM, so that hallucination problem is solved?
So, I mean, if you remember during the presentation, I was talking about reflection pattern.
Yes.
So what reflection does is, so let's say if the LLM hallucinated and it was, let's say you're talking about maybe some recent news. You might be talking about a financial bank, but it might be talking about something else. Then reflection pattern would actually go ahead and reflect on its output. Let's say it hallucinated and it gives some information which is not relevant. And next time you have the reflection pattern that could be the same LLM analyzing and saying, is this information relevant to the query that is asked or not? Is it 100% right or not? That is something that it will reflect on. Or you can create a multi-agent where you say one is the generation, the other would be validating that facts. So one could be a validator, fact validator agent that is actually going out, getting that output from that generation initial, maybe a content writer, maybe in our case, let's take a content writer. A content writer hallucinated, it generated content which is not relevant. Now a content validator validates it and see if that content is validated, it's according to the company policies, or is it even relevant to the company or not. Then it will think that if it say, oh no, it's not relevant, you hallucinated, or maybe this information is not even relevant to this, then it will again go back and will generate the content again with the feedback given. And now there is a chance that it might not hallucinate because now it gets more context. It will the validator would give more context to that and say, hey, this is not related to this topic, it is related to a different topic, and give that context to it, and there is a chance it can come back and and eliminate that hallucination, so it will not hallucinate. And you should also look for the source of hallucination. The biggest source of hallucination is the prompting itself. If you don't give good context to your agent, to your LLM, it will hallucinate. So you should able to properly optimize your prompt in order to reduce the hallucinations. You should tweak a lot of prompts, use framework like DSPy to come up with different prompts to see where it cannot hallucinate, and also add more context to it. If you give it end-to-end context, then there is a very less chance that it hallucinates. So that is one
Okay.
of the reasons why agentic really helps in that, because you're doing multiple calls to LLM, right? That is what you're doing here. You're just
Hallucination.
yeah,
Okay.
go ahead.
So
Go ahead.
hallucination could be in any way. For example, if we take a small example, like 2 plus 2 is 4. If we ask the question and LLM says 2 plus 2 is C. So that
Yes.
could be one of the type of hallucination which you talked about, like it is irrelevant. But what if instead of 2 plus 2, 4, it says 2 plus 2 is 5? It is relevant, but it is wrong.
Okay, yeah. So in that case, when it is relevant and it is wrong, so there are two things. One is checking for one is the verifier, well, and the other one is a corrector, right? One is just verifying if that is even a number or not. The other one is actually checking for its correction, right? So in that case, LLMs are very bad at algorithms. So you cannot have LLMs to do math for you, right? I mean, in general, I am talking about your use case where you're trying to when things can hallucinate. So hallucination would also imply if in case you probably need to use external tools like maybe a calculator to do that calculation. That way you can reduce that hallucinations because you're understanding the limitations of your model, right?
That is
Hallucinations.
fine. I just took an example for better
Yeah,
understanding.
if you just took an example and okay, maybe in your
I,
case, there's an example. You're talking about two kinds of hallucinations. One is
yes, yes, yes.
related to,
Hmm.
okay, now I understood. So one you're talking about, hey, this is where you're hallucinating, the extent of hallucination, right? One is hallucinating in a way where it is completely getting mistaken of the context altogether. It has to reply by a number. In some case, the context it is right, but the fact is wrong, right? So
Right.
that is how two different kind of hallucinations. So same thing in that case, you can still use agentic to get those to eliminate those hallucinations. In that case, you just add one more agent, and as I said, these agents are domain specific, so they have to be specific to which domain and what problem you're solving. Those
Okay.
agents are not generic. You
Okay.
can still create generic agents. In that case, you're basically again doing a feedback loop. Every time it generates a fact, it has to prove that the fact is right with a specific reference. It has to
Okay.
do a check of that source saying that, hey, this is a fact and this is the source link, which is actually telling about that fact. And this is from the right source. That way you can reduce that hallucination as much as possible. But these agents are more generic. They are more domain specific. If you want to make them less hallucinate, you have to make them domain specific. You have to make them narrow down the domain that you're targeting. If you say, okay, I want to build an AI agent that never hallucinates, that may not be that. It's a
Possible.
generic AI agent that never hallucinate. Maybe that maybe you cannot do that because you're increasing the um, space, and also these missions are basically probabilistic, right? They're just predicting the next word. That is what they're doing. So there's a very high scope that they can hallucinate if you're not narrowing down the domain that they are
Okay.
working in.
Okay.
Yeah, that is.
So one more question. Can we say that AI agent is a type of chatbot on LLM? Can we say that? Or it
It
is
might not always be a chatbot. It might not always be a chatbot because they could be AI agents which can just come up and give you a response to something, right? Maybe, yeah, it is your question. You have a question and you have this AI agent that's coming back and giving you an answer. But in some case, your agent may not just be chatting. You can also give some images to it and it can analyze that image and come back with some research and does some analysis on finding if that image has like maybe a construction site image and say what are the places where you feel like maybe some areas that safety could be improved, right? In that case, the agent is multimodal agent because it can understand images as well, and it is answering questions more of like not like a chatbot but more of like maybe a safety inspector, right? So application there would be a AI agent safety inspector. In our case, yeah, whatever we're doing now, yeah, it might sound like a chatbot, even like video generation now, the process that we're doing with video generation, it is cannot be a chatbot, but what I'm telling is, hey, this is what I need, or you just work on this, and then it is just coming up with an output. So this agent is not a chatbot, but it is getting some basic information from a human, and it is working on some task to come up with a specific task, right? In our case, it is generating content. Yeah, there is two modalities to it. The first modality of chatting, where we are just getting some text output. There could be other modality where it is actually generating the content itself. In that case, maybe chat model may not be there. And chatting is only a specific fine-tuned version of a base model. Actually, these LLMs, there are different kind of LLM. There's an instruct model. Instruct model is, it will just follow instructions, but it is not chatbot tuned. There are some which are only specific to chatbot. And there are some models, these instruct models which I'm talking about, they can be used for scientific research. They are models that people are using to invent new material. They're doing people building scientists itself, like PhD scientists doing actual research.
Mhm.
So those are not chatbots, those are AI agents, which might not be tuned to be a chatbot, but they are tuned to do some cognition work to go and look for patterns and see how they can push the limits of metallurgy research. And they're already doing that. There are a lot of research papers outside where these AI agents are actually coming out and giving out research findings. Recently, Google came up with an AI agent. I can share that link, which is a agent co-scientist. They call it so co-scientist. It was able to. It was able to. It was able to invent. It was able to help one of the researcher to come up with some medication for superbugs. Superbugs are something that are really reluctant to antibiotics. That scientist was doing research for 6 years, but now when he was using the Google's co-scientist agent, he was able to do 6 years of research in 5 minutes. It was able to find all the inference, and this data is not on the internet, by the way. All this research that he did, it was actually in his own personal laptop, but it was able to do or dig more research, do 6 years of research in 5 minutes, and was able to give that all of that research findings to him, which really was surprising, right? I mean, how can you I mean, I'll share that thing to you. I think it's from a
Sure, sure. That would be
uh,
helpful. Yeah.
yes, I'm sharing that right here. So just don't think agents are just limited to be chatbots. No, we are entering into a domain where these agents could be scientists working on pushing some of the issues that we have, like helping us with maybe finding medication for cancer, right? Which is really important. Medicate, or maybe solving climate change. Yeah, we might speak about maybe a agent today for creating content, but these agents are just not limited to content creation or just chatbots. I think by using this planning ability, the research ability of this, you're scaling up the cognition task and doing something really big. So software engineers, I mean, how many of you who joined this call, please don't be insecure that, oh, you know what, LLM or AI can take my job. Please don't think like that. What I would say is, since you already know coding, you already can write code in APIs and all, you actually got a powerful weapon now that can help you to solve bigger problems, not just still doing the UI work and the backend work, or maybe writing some APIs. I mean, yeah, that is all boring work that we're going to give to AI, but we're going to solve bigger problems. We're going to solve bigger problems to fight climate change, maybe create AI agents together can come up with best economic policy for India to achieve, maybe to become the developed country even faster. I mean, I know it's not AI agent to do that. It's all in politicians' hand, but still, we can create better policies. We can create better drugs, better food for our people by having this cognition, because we can't scale up on number of scientists, but we can use these AI agents or build AI agents to scale up the research process. That is how innovation grows. Yeah, but yeah,
Oh,
look at thing. It's a great article
sure,
that
sure.
you can all
Thanks.
follow. Okay, yeah.
Next
Okay, thanks.
question.
Thanks, Raj.
Next
Anyone?
question we can have from Manu.
Yeah,
Yeah, Anu.
yeah. Hi, Raj. So, Raj, you mentioned something about using blended tools and architecture. For
Oh, yes.
example, LangGraph and CrewAI. So, I wanted to understand what is the thought process on when to use what.
So basically, LangGraph and CrewAI both have their own pros and cons. So CrewAI is really easy to implement when you have a hierarchical structure where you have a process that you want to get an output, and you want to divide this whatever task at hand, you want to divide it by mapping it to hierarchy, right? Hierarchy, I mean, just like how we have teams of a manager and lot of subordinates who are distributing the work and reporting to a manager, and manager validates it. So a task like that would be really complicated in LangGraph, because LangGraph, you have to create a bunch of nodes. There's too much of code to debug. LangGraph can get things really complicated. Previously, CrewAI didn't supported. It didn't supported something called there is something called a flow stateful architecture. So you cannot create multiple stages. You can't guide them to something. But now CrewAI came up with that. They call it as flow. Just because Crew is easier to implement, but there are certain things that you can implement in Crew easier and with less lines of code when compared with LangGraph. So that is how you can come up with a trade-off, either to use CrewAI or to use LangGraph. And also, many of times, I would say, please don't even consider these tools. Your work would probably be done by a simple LLM call or maybe a couple of LLM calls. So don't get yourself complicated, or don't get yourself into getting into all these tools, because they might make your product or whatever solution that you're developing too complicated. So first assess and see whether even framework is needed, or maybe a simple LLM call is needed. If it is a simple LLM call followed by a validation or a couple of LLM calls, just don't go with any of these frameworks. Just go ahead and use maybe OpenAI APIs or maybe any other APIs to just call and perform your task. But in our case, since the task is huge and we want memory to be incorporated, so we kind of use both together, CrewAI and LangGraph, to balance out the workload, the cognition workload that we're trying to solve. That is a trade-off that you can do. But we use it in combination to solve some problems.
So when you say cognition workload, sorry, I'm a product manager, so I'm
Sure. So go ahead. Yeah, that's great. Yeah, go ahead.
So I'm just trying to understand from the code point of view, when do you get to know that the cognitive load is sort of high? Like this particular task will require higher load.
Yes. So yeah, that's a great question, by the way. So imagine like you have an agent that is just telling if that email is empathetic or not empathetic, if that email is addressing a customer feedback or no. That I can say out of 1 to 10, I would say 2 or 3 as cognitive workload. What does an 8 cognitive workload looks like? Oh, maybe a product manager agent co-pilot for you, which will look for all your documents, and it has to tell you whether this ticket or this product feature can actually result in the best outcome for your business or not, based on all of your previous features that were developed in your product, based on your customer feedback, based on your manager feedback, based on some of your previous documents, analyzing everything individually and coming back and telling you, hey, this feature could be improved or this feature could be implemented because this is what the business needs. That would be 8. If you ask me about 10, can you go ahead and find the best drug for this disease? That would be 10. Maybe there's beyond 10 too. Yeah, but that is how the cognitive workload is. You see, right? So when I'm talking about a co-pilot for product manager, it has so many integrations because you have to look for so many sources to get tools and documents from different places. So that is tools that an agent would need, that to multiple tools. It should also know when to call which tool. That is called function calling, because these LLMs should be really good at knowing when to call what tool to answer a specific question. So that is a huge cognitive workload that you need to address. Even in our case, video generation or content generation. In order to generate that content, you need to, okay, maybe it is a video generator agent that is doing, maybe your AI that is doing the video generation, but to plan out which script, how the script should look like, and all of this, right? That entire thing would maybe to plan out a story, to make a movie, it should have it is a huge cognitive workload, right? So that is what cognitive workload actually means. I mean, I don't know how many would use that word, but I usually use that in most of my presentations. But yeah, that is how I divide that into different levels.
Got it. So when the work is more exploratory or it has too many decision making,
Yes.
not per se technical wise, but more sort of probability wise, that this is the higher risk or the whatever, the outcome will be much better, then in that case, the workload will be higher.
Yes. That's, yeah, just like a simple task versus a simple task, someone saying if that is email is good or bad, to someone saying write an email that, maybe by analyzing a lot of documents and everything, or maybe a doctor making a decision, right? If a doctor has to make a specific decision on something, maybe, they have to put a lot of thought process into it. Maybe designing a home plan, that requires a lot of thought process. That cognitive workload is more. So yeah, that is how it differs, because in that case, decision making is more, right? Yeah, you're right on point. That's what that makes the difference.
Got it.
Yeah.
Thanks.
Thanks a lot. Yeah, great question. Akshit?
Next question, Akshit.
Thank you, Raj, for the session. It was actually very helpful in getting to know what is happening and how we can make the best use of it and advance ourselves. So with me, there was one problem. I also had my office going on parallelly. So I was on and off. Would it be possible for you to just summarize the gist of what we talked about? Um,
Okay.
yeah, would it be possible for you to summarize the gist of what we talked
I mean,
about
maybe
today?
I'll take a next question, but I just spoke about AI agent, content creation agent, but you'll have a video of this, so you can always go back and check it. I would recommend just go ahead, take that URL, put it in a Google summarizer or something. You'll get a summary of it, but I can give you a maybe a few line summary just about content creation agent and AI agents is what we spoke about in this. Okay, Akshay, is it Akshay that spoke to?
Yes, yes, Akshay.
Yeah. So yeah, it's just about content creation agent is what we're talking about, but you'll get access to the video, this recording and all. So please don't worry about this. You can always go back and review this. Okay. Yeah. Gokul, can you please go ahead with
Hi,
your
Raj.
question?
So actually,
Hi.
the conversation is very good and had a good understanding about this Gen AI stuffs. And I am just new to AI, but I'm a senior engineering manager in like a product-based company. So just have a couple of questions. And like right now, all these foundational models and this chat, like whatever agent we are creating, right? Whether in future it may converge into kind of a foundational models or in future, how would it gonna evolve? Like for if a company want to do any use case like a Java developer or React. So every individual use cases, we want to choose a individual agent model to ask for the things, or it can be a general model like ChatGPT or Grok, or we can directly put our questions and get the things done. So I just want to understand how, like, because we have different foundational model for each use case, and also multiple agents have been created for different domain things, right? So whether it gonna converge at one point in future, or it will be like separate, or how we want to look at the things, because it is completely new and like all this momentum is gaining within this 6 to 1 year, 6 months to 1 year, right? So where we want to invest our time on learning the things, so it can be, because every day we can't be updated with which model is better, like O mini is better or 4.5, or this crew agent, or what like a lot of agents also coming up. Like as a kind
Yes.
of engineering manager to data science, I feel how I can keep updated and how the things can evolve in future.
Yes. I mean, so first thing, since you are an engineering manager, I mean, if you come from a developer, I presume you are from a developer background, right? So do you come from a development background, Google?
So I was a Java developer and managing a team
Java
of
developer, right? Yeah. So
mobile
basically, yeah, so there are different ways. I mean, any developer now, I think you can all develop agents. It's not if you want to be a developer in that space, or even data-driven decisions. You're engineering manager, so you see metrics. So knowing if your agent is doing better or wrong, you can still do it. So you all are already in that space already in that space of building agents. So I think anyone can get into AI with building agents because you already have programming background, so you know how to build agent. If you know how to build an agent, previously you know how to build a static CRUD application, but you know how to build a copilot for a doctor. You know how to build a copilot for different areas, different sectors. You can also build a scientist as well. So you know how to play, but the only thing is the way you think now will be different. Previous applications never changed. They never changed their behavior. Now you have to think your application to be a human because their cognition levels have gone so up. So you basically have to think about them as you're chatting with a colleague, right? That is how you need to treat them as. I mean, yeah, they have their own disadvantages. No one would trust AI. I would not trust a AI. Maybe I would not hire an AI for Google instead of Google, because I always need Google to give me the ultimate decision by making use of AI as a tool. But I want AI to accompany Google. So if any of my developers come and say I'm not using AI, I'm not really happy about it, because I want my developers to be using AI. Otherwise, their productivity gains will go down drastically. So one thing is to keep up with this. What is the intersection to answer that? So what the trend I'm seeing now is AI agents were actually in the beginning, like last year. I've been developing AI agents since like 2023, end of 2023, 2024. We got these frameworks, worked on frameworks. The thing what we did was initially when you ask LLM how many R's in a strawberry, right? Or maybe answer some questions around which is greater, 9.9 or 9.11. So these questions, LLM would fail. So what we did was, as part of agentic, because LLMs cannot answer that question, or strawberry, how many R's in strawberry. But if you give it access to Python tool and tell it just go ahead, write up code to find out that answer, it would probably do that. It will go into that, use Python to split every word, count every R, and come back and say, hey, these are 3 R's. That is what it is. There are 3 R's in this, because now you are basically creating agentic layer with tools to do that, enforce that reasoning by giving it tools, right? To the thinking process. We are just enforcing that by doing this agentic approach, and we are doing it even now. But the things which are changing now is the foundational models. This reasoning thing is, the reasoning traces are baked into the model now. If you see O1 model is coming up with its own reasoning traces. They're thinking. They're not just answering. They're just not answering with the next word. They're not predicting next tokens. They're actually thinking just like we humans. It's a new thing, that is a new shift altogether. I mean, I'm really surprised today. DeepSeek came out in a couple of months ago, like January. DeepSeek came in, it just crashed NVIDIA. Today, Quen model came out, which is like, how much? It is 32 billion parameter model. DeepSeek was 600 billion parameter model, which is huge. Quen is 32 billion, it's very small, but it is beating DeepSeek now with the reasoning power. What made it possible? Reinforcement learning. So the model started thinking. They're getting smarter. They start to think like humans to answer it. While last year we used to build agentic workflows to do, just to check if how many R's on strawberry to give by giving tools. But now those small mistakes, they are able to come out and say, hey, I will not hallucinate anymore because I'm thinking just like human. So agentic workflows or patterns that we're building with these frameworks are not just limited to just reduce the hallucinations or things like that, but also to enhance even more cognition, enhance them to do better research, and also make them smaller and mightier. So smaller models are itself getting way smarter. So you're seeing that shift. So things are getting smaller and they're becoming smarter also within just a couple of months. The foundational models which are going to power going forward, I feel like, with reinforcement learning. I mean, reinforcement learning is really powerful. I mean, if anyone is in Bengaluru tomorrow, please do come for this session. I think Shivani will share you that. We'll be going through a lot of RL. I mean, not too deep. We'll be going through some fine tuning using RL, because reinforcement learning is really taking off now. But going forward, that is what happens. So you'll get the models being very smaller and they'll be becoming mightier. And today's news with Quen is the thing that you see. Agentic will still be there, but the agentic approach will be getting even smarter, and function calling ability is something that is very important in this model. So what makes function calling very helpful? Previously, when we were talking about having a product manager co-pilot, you see a product manager should make a lot of decisions, and they have to use different tools to get information. So your agent should be able to know which tool to call at what time. So that is what function calling ability is. So your agents will be very smarter if in case their function calling ability is really high, and that is going on high now. Like the Quen model is able to beat even the DeepSeek model in using tools. So going forward, these agents will be very reliable. So you're seeing that blend of both. This foundational model itself, reasoning power are going high. So these are not machines which are just predicting next word. Maybe next year I would not say, oh, these machines are just predicting next word, because RL is making them think like humans now. So they are actually they're actually becoming more smarter, is what I can say. So foundational model, as they become smarter, agentic patterns or agentic work frameworks will make them even smarter to solve bigger problems. So yeah, that is where we are trending. That is the trend we are in now. I can share you this new recent article, like this just came out today, the Quen model. It's from Alibaba. So I can share that, how it is able to beat it. But yeah, and in order to be, if you want to follow all of this news and everything, you can follow Cerebron page. We have all of these recent things that we post on LinkedIn. Just follow our page or follow other pages to get up to date on what's happening in this AI world. We also have a WhatsApp group where we keep on posting different new trends, because every day we have something new. Even I learn from my own pages, because we have that automated. We have our content agent that is going out to different sources and getting me this content, and I'm following it to learn about this. So, so I think I'm sharing this right here, which is how this recent DeepSeek model.
And also one more question on like whether like this domains will be across industry common, or we can put it a company specific subjective models for each companies, like because we are into fintech, we want to have proprietary data and we can use model to only
I
support them.
think,
Or how when it will be decided it can be open source model and like consider for any compliance perspective across
Mhm.
in compliance it can be used. So how the training data set will be used and how we can switch between whether to decide like it need to be subjective within company proprietary, or it can be a open source at agent.
So agent is more of a framework, but are you talking about okay, oh, whether to use open source frameworks in fintech or not, right? Is that what your question is? Could you
No,
please?
like, so agent, once we create a framework, consider like how we have a GitHub Copilot. It is
Yes.
helping developers productivity. Tomorrow, any for
Yes.
compliance perspective, we create some compliance Copilot for any industry. So across
Yes.
other companies also can use it as a product, or it can be like industry, like only
Okay.
company specific. We can
Yeah.
create and keep it. So which
Yeah.
one?
See, yeah. I'm sorry. Yeah. I think I can answer your question now. Thanks for that reiteration. So basically, domain specific agents always win, because when you're reducing the scope, I think we already had this discussion before, I guess, because when you're reducing the scope to one domain, you're making the accuracy go up drastically high, because now you're not targeting a lot of domains, a lot of data that is coming, that is very dispersed across domains. Now you have this only fine-tuned to your domain and with your own data, and that to that personal data within your own environment. And with fintech will probably benefit by that, because as these models are getting smaller, everyone can have a small language model that is fine-tuned to your own domain. And you don't need to have a large model like DeepSeek or even OpenAI, because those models are proprietary and those are closed source. I'm sorry, not DeepSeek, only the OpenAI model. DeepSeek you can also host, but usually resources are really high, because 600 billion parameter really take a lot of resources. So, but you can have a small language model that is within your own environment, it's sitting in your own private network and giving your inferencing and using your own data within your within your own firewall. So that way you're also taking care of your compliance. Maybe you can create a data pre-processing pipeline with all of this masking and everything. But end of the day, having that domain specific will always win. And I think most of the enterprises will actually have that going on pretty soon. They'll have their own models hosting inside. Maybe open source, small language models that they can use, rather than developing something foundational. I mean, foundational models do work, but I think foundational model generation or development would happen by bigger players. I don't think any even I mean those are very big, because those are commodities. They could be treated as commodities, not like not anyone can do it, and they're just wasting resources if they really want to do it, because there are big companies already doing it. But we can just tap it and distill that knowledge into smaller model. And distilling that knowledge also, you're not distilling all of the knowledge, you're only distilling knowledge that is needed for your domain. Then your model will be even better than the proprietary models. That is a win for the company, any enterprise.
Okay, fine. And also this agent creation can be a kind of a SaaS product in future. So it
There are
can
a lot
be.
of agents coming up. Yeah, absolutely. It can be like a SaaS. I mean, people are saying SaaS is dead because SaaS is more software as a service, so it's all crud. But now, you'll have all of them being agentic, so they could probably be more of like any modality. You don't have to open a UI. You could probably talk to them or chat with them through a text message, or even your agent itself will interface with other SaaS products. So everyone would have, maybe your Facebook agent would probably talk and get you best. So maybe your recommender agent will talk to other agents to get you the best recommendation possible. So that, I mean, we're still early in that phase, but I think going forward, the future will be where agents will have their own authentication layer. They will have their own protocols, and they will have their own security, where we don't deal with going into UI and opening and clicking buttons. Rather, every product will have their own agents, and your client agent will talk with those agents and get things done. So that is what the future is. So people will not be wasting time opening and navigating UIs and everything. I'm talking about like 3 years, 4 years from now, till everyone is really confident that agents, and also there's a robust concrete protocols that are generated around agent to agent protocol, speaking protocol. Things are already there now. Agents can actually make payments as well. Stripe already released a API for agents, specifically for agents to make payments on behalf of you. So yeah, we are almost heading in that direction. It might happen soon.
I think that was all the questions. We have some questions in the chat. If you can answer.
So Ed, tomorrow's event is live. It's actually in person. Okay, you're not in India. Okay. But that would be more of like virtual as well. I mean, we don't have a virtual as of now. Okay, DeepSeek versus Penny. Yeah, thank you guys. I think there's a lot of you are supporting us here. So for enterprise production level, which is a recommended framework, LangGraph people can use. Yes, India is definitely low on resources, especially research area. We only spend 3% of our GDP or even less than that on research, R&D. So any agents in research would definitely help. I think defense will also be opening up for AI going forward in the next 2 years is what I'm predicting. AI, Indian defense, I mean, even HAL would probably open up. ISRO is already doing that now, so definitely we'll see a lot of progress there. But yeah, definitely R&D is something that pretty soon will be offloaded to AI, and India will definitely benefit from that. Yes, Ed. It can probably get you from your own. You're basically grounding your agent, so you're basically adding your data source to ground it and have it only generate or use your own data um, rather than just doing external. So you're basically grounding it by your own databases or using graphs as well. I think we spoke about it last meeting, last session, using RAG. So it's similar to RAG. Could we have the agent curate the content instead of generating it? For instance, have the agent take videos from our Google Drive based on the description prompt? Oh yeah, that is possible. I mean, that is the best way to do that, Asto. I think because instead of having you generate videos, which I mean, AI is not that great yet, but you can still curate it. In that case, what you're trying to do is something called multimodal RAG, where you're searching through the videos. So your model should able to search through videos. It has to understand the context of every part, every image in that video. So that can happen through something called multimodal RAG. I think it's still evolving. They're like tools like Colipali. I think we discussed about it last meeting in RAG, but I think it's an important use case. Probably we'll solve some use case like that going forward, where we'll be having this curation or searching to the videos to create the content. In that case, only thing is you're not using just LLM, but you're using a VLM, which is a vision language model, which can understand the image or understand the video as a whole. There's also to share something else here. Okay. So I think the video got generated, which I've just did for Holi. I just want to see how it was, but yeah, I can share you that. I'm just playing that in the background. So hopefully I answered that question as to okay, any questions, anyone? I do see there's some discussion and I think it's a great session. I see everyone collaborating. I think that is the whole purpose of this call. And asking questions. Let me see down. Agentic RAG, I think you can use LangGraph Pydantic AI I haven't used, but I heard it's really great. I mean, we use a lot of Pydantic even in LangGraph, so I think their framework would probably be more efficient and easy. So best for agentic RAG, I mean, you could use any of these tools. I never tried Llama Index, but I know people using Llama Index because of its good connectivity with a lot of enterprise tools. But it also depends on where is your data in your agentic RAG. Is it just simple agentic RAG? And you can also use that through LangGraph may not be needed there because agentic RAG would probably be more of React. It is probably going ahead and checking if that retrieval is right or wrong. So it's not a too complicated decision to make. So I don't think LangGraph might be an overkill, but you can use simple LangChain, RAG modules to check for it. LangFlow is more of like, I think it's is LangFlow, I think LangFlow is just observability, right? I mean, I have to check that. LangFlow. Oh, it's a low code builder for agenting and RAG up. I'm not aware of this actually. LangFlow. I have to check this. It looks good. It's a low code AI builder. That's great. So the video generation is done. Let me share that. Let's see how it generated.
Welcome to Holi, the festival of colors where markets burst with vibrant hues and joyful energy. Experience the joy as colors fill the air, laughter echoes, and spirits soar. Families gather by the bonfire celebrating unity and the triumph of good over evil. Capture the moment, share the sweetness, and spread the joy of Holi. Join the playful chaos where laughter and colors unite us all. Let's celebrate Holi together, a festival that connects us all through joy and color. Welcome to Holi, the festival.
The sound is making, I don't know, there's some issue with the sound. I don't know if it is because I'm sharing the screen but the sound is really not that great. But yeah, maybe there's a lot of room for improvement here. What I feel like is finding the best video feed from already existing video feed and generate content.
Raj, your audio is not very audible.
Oh, now?
Yes, now. Before the video it was, now it has gone down.
Yeah, because of some issue with the audio, because there's some issue going on because when that also playing audio, so it's usually
better
have
now.
some. It's better now, yeah. Thank you. Oh, can you tell a framework or workflow for consistent character generation? Asked by Srihari. Okay. Consistent character generation, I think you could probably do that by having a proper prompting, or even there are a lot of some in Midjourney, there's something called srefs that you can use to generate a character in certain styles, and then use that to generate the similar images that can be used, or you can use Confi UI or some other frameworks to make your character more consistent with the styling and all. So even your prompt can also help to make your character a bit consistent. There might be other ways as well, which I'm not aware of, because I really love this domain of creating videos with AI, but I know consistency is a huge problem here. If consistency could be solved, I think movies could be made easily. But I think there are people who are solving for that, but not directly. But what they're using is they're using their video feed, but they're using AI to edit that video feed and make it and use real video along with AI and the blending it to make the video more consistent, or just add some new assets to the video. I think recently someone made an ad by using AI. The character is human itself, but they augmented other things, graphics and everything with AI. With which agent builder is best in terms of tool calling and knowledge? I mean, tool calling and knowledge usage, tool calling is under the hood. It's actually the LLM that has to be good with tool calling, because tool calling or function calling, it's the LLM that actually makes the decision. There is a tool calling leadership board called BFCL that you can look for, where you will have different tool calling leaders, models which are good with tool calling, and you can make use of that model to build your RAG system. I think that would be a good way to do that. Maybe to decide upon which is the best tool calling agent. I feel like now Quen model is doing good with terms of tool calling. The BFCL, this, wait, let me check. Tool calling leaderboard. Yeah, it's BFCL only. Yeah, let me give you the link to that. I think it is even hosted. Yeah. Yeah, this is the link to that, where you can actually find the tool calling, the model that has the best tool calling ability. Okay. The audio in the video is very white and not authentic. Yeah. I mean, it could be improved, but today, you know, we had no other option because we had to use that. We were using a different audio text to audio framework, but that requires a credit card to sign up. So we just felt like, okay, File AI could be the best, so that there's only one API key that people can put and get started with it. Yeah. So yeah, great talking to everyone. I think if you guys have any questions, please do follow along. I mean, you can pass along those questions to Shivani or post them in our meetup group. But yeah, thanks a lot. Great talking to everyone. Hope everyone have a great rest of your day. Thank you.